Next up on our schedule is a presentation by Amy and Sahar about using sales models in Jumpstart. So hopefully everyone's back. I'm just going to assume everyone's back. You guys want to take it away?
Sure. Is Sahar there?
Make sure yeah, hi.
Okay, great. Okay, cool. Here we go. Let's get that one down and do this one. Okay, so Revit at Jumpstart, finding ways to use the Revit model to analyze building geometry and system design from the sales model at the very beginning, and then hopefully throughout the shop drawing process. So back in February, oh, by the way, we have a Jamboard. Sorry, let me put this in here. You can use the chat like people are doing, or we can, I'm just gonna put the link in here and it should work. Okay, where'd you go, chat? There you are. Why is it not showing?
Yeah, when you share your screen, chat disappears. It's pretty annoying.
Or there we go. Jamboard. Here. Okay. All right. So if you have questions, you can use the chat like people have been doing, or if you want to go to that Jamboard, I just checked it. It should have access for everybody. So, okay. So talking about taking it to the next level. So we met back in February, actually in person in Fremont, and it was Steve Larson, Steve Watts, and the Jumpstart team. And so they started talking about other ways that we could start to use that Revit model early on to help the Jumpstart team. And so what we did was we talked about what you can get from Revit. Like, here are some things, some ways to use the data that you can get from Revit. We talked about schedules. Schedules are a good place to start looking at data because they're easy to set up and you can manipulate and filter and get a lot of information that way. But sometimes you need to go beyond a schedule. Schedules do have their limitations. So we talked about using Dynamo. Could Dynamo work for what they want to do? And then we talked about, we could also potentially, you know, if we need to add more parameters into the model families or into the project file or anything like that, because the other two things weren't giving us what we needed, you know, there's always that option too, to continue to evolve the modeling tools. So, and a lot of times you can use both schedule and Dynamo can be used together. So again, this is just exposing the Jumpstart team to some ideas of how they could get to that data. That's, we're just talking about a little bit of history. And so if you don't know what a Revit schedule is, this is a screenshot of a Revit schedule looking at the glass sizes in a sales model. You got the glass type, the glass area. That one actually shows the setting block length. But anyway, they include the columns that show values for the selected parameters. They can be filtered. You can add formulas in a schedule to mess with the parameters and get something else derived. Column values can be combined like concatenation. Schedules can be exported to Excel and be further manipulated with that. Data can be added to an Excel spreadsheet and imported back into Revit to add more information into the model. So an example, again, getting setting block sizes. This was an easy one they mentioned very early on. Could we get setting block sizes from the model? So what it does for this schedule is it looks at the square footage of the glass and the width of the frame to determine the setting block size. And it looks like this. Again, there's a formula in there for getting that setting block length. And so that formula is just real basic. It's saying, if the glass is not greater than 40 square feet, tell us 4. If it's between 40 square feet, but not between 40 square feet and 60 square feet, give us a 6. Anything else that's above that, give us an 8. So that's a very basic way to put a formula right in a schedule. But it doesn't tell us where they go, so it's still limited. Revit schedules in conjunction with Dynamo can be used, again, to get data back into the model. So you export the schedule to Excel with Dynamo. You can edit that Excel file there, and then you can import that data back into the model. What is Dynamo? Dynamo is visual programming. So this is just a quick screenshot of Dynamo. You've got nodes, all of those little guys there. You've got wires connecting the nodes. And basically it's an easier way for people that don't have a lot of programming background to do some programming, because behind each of those nodes is potentially some other code, maybe some Python script. So this is behind one of those nodes, and in that node there's Python script, and in Python then you get to the root of stuff. So it can have these layers, and you know, you can do a lot of stuff, and this is all customizable. So again, it's open source, it's free, it can be used in other programs besides Revit. It's just makes it easier to program because you're just connecting wires, and they can manipulate geometry, work with parameters and data, and work with views and sheets and do all kinds of other stuff. So this is just an example right here of which frame has the biggest piece of glass. If they wanted to find out where the biggest piece of glass is on the project, there's this script, and you can see that it's looking at, it gives us the frame ID, it gives us the glass square footage, and it tells us it's vision glass. So that's just part of this other script. This is just giving you a background, you know, again, just showing you what's possible, and without getting into heavy programming. So that watch node is part of this guy. And this is where we're just playing with all kinds of different stuff in here. But ultimately, it's really just looking at the curtain panels and pulling some other information, the sub parts. So this is a little video of just real quick of how you can do that export import. So you can see right now, if you look over to the right, all these frames, I'm looking at the unit number, they're all set to 000. So then we're gonna run our script in Dynamo, and we're gonna tell it to write some data to a blank schedule or a blank Revit Excel file. And then I'm going to add some unit numbers here, and I'm going to save that file. And then I'm going to go back to Dynamo and open the other routine that does the import. And so then you browse to your Excel file, and you run this routine, make sure it's going to fill in the unit number parameter, and it's going to run. It took a little bit longer to run than that. I just wanted to save time. It takes a minute or two. But now if we go back and check those frames, we can see that that unit number is now filled in. It's based on the location ID, the identity of that frame. So those are just some examples. This is my our shameless Dynamo lead plug. If anybody's interested, we do meet, and we meet every 2 weeks. It's a work session. We talk about scripts, we share ideas. We try to share helpful information with each other, and send me an email if you want to get into it. Okay, back to the subject. We have, there are other important things to understand when researching new ways to get to that Revit data. So how soon will the data be available when you're starting a bid model? How is the modeling structured? These are all things that they're going to have to understand. Where is the data hosted? Will it be available throughout the life of the model? And then narrowing down which data you actually need to get your analysis going. So key points from just that real quick introduction run through: try the simplest option first. This is all, you know, what we were talking about back in February. Try a Revit schedule. If a schedule can't provide what you need, try Dynamo. Sometimes we need to add parameters with the tools. Maybe you need to use them together, and then do the import export. So these are just some basics before getting into heavy programming. So the next steps after we talked about those things was the Jumpstart team members. They need to learn about Revit modeling structure and format. They learn about creating schedules and how to work in Dynamo if they want to try that out, see if that's an option. And then they start to form a vision of current and future possible things that they could do with, you know, for analysis. So that's what we talked about, and then we left it to Sahar to go ahead and tackle that big that whole process. So I'm going to stop share and hand it over to her.
Thank you, Amy. So I'm gonna give you guys an overview of what is going on before drafting or takeoff or anyone else sees the profiles and uses them. So when estimating, when we decide to bid a project, we get bid documents, project documents. And these documents are being used by 3 different teams all at the same time. We've got estimating using them, sales model team using them, and Jumpstart using them. And we're all getting information from these documents, processing the information, using the information, making decisions, processing it, and then determining all sorts of different things and feeding each other more information that we need to complete each of our tasks. So some of the process flow here is estimating, reviews documents, makes some decisions, and then gives Jumpstart information that helps us make our decisions. They give sales model information that helps them model. Jumpstart uses the bid docs and the information from estimating to make decisions and find limitations, and then gives that information back to estimating, gives some of that information to the sales model team so they can model. And the sales model is also communicating mainly with the estimating team and giving them what they need. So to review sort of what Jumpstart does, we've got, as most of you know, we've got 3 packages: Jumpstart package 1, 2, and 3. And we do the packages in that order. The first package includes all relevant information that we use to engineer the building. We compile all of it and document it in one package, and we send it off to the estimator, and that's the first package that they get from us. The second package is where we do the engineering. To do the engineering, there's 2 main things. We use Excel that has equations already built in to certain Excel sheets, and there's some other programs we use like C-Beam, Simple Beam, and Window Glass Design for glass deflection. But these are all equations and derivations that we can determine or have determined. And the way we use these programs is we have values that we input into the equations. Those values can come from estimating or the bid project documents. Again, this is really important because we all process the project documents. All teams in engineering, we all process the project documents, but this is where we first see them and process them. After we do the engineering, we start with Jumpstart package 3, where we draw details and we draw any new parts or dies that we need. And so this is the current process, and this can change in the future as we look at using the sales model to our benefit. Future visions, we hope to use the sales Revit model to run the calculations. So with the press of a button, the model will run the calculations for us, and then we can analyze what it has done. That would give us more time to draw details, perfect the details, and draw and determine new parts needed. Where Dynamo comes in is it's really helpful with processing and organizing data. You can get the data from the model, you can process it in Excel, and then you can feed it back to the model. So this is just an overview, and it shows how estimating, sales model, and Jumpstart is truly working together. Everything is happening at the same time to help estimating get their estimate, send out their estimate, and send out details of what the exterior skin will look like. But these details, at the same time, we try and are expected to make these details shop drawing quality. And so from the beginning, we do our best and use standard details to help us with that help you guys downstream. And once the project does become an actual job and has a job number, we go through all of these, we go through these 3 packages again and compare them to the recent project documents to make sure that any changes are reflected in the packages and that the details are as perfect as we can make it for downstream. So with that, I'm going to show you guys an example of what I'm working on and how it started. So one of the checks that Jumpstart does is check the horizontal mullion deflection. So we check the dead load of the glass, the weight of the glass, and see if the horizontal member can handle the weight of the glass or if it will over deflect per ASCE standards. The program that we used to use and that's still available to us is Simple Beam for mullions. Simple Beam has lots of different options. It mainly looks at 2 anchor points. So if you've got multiple stack joints, you can't really use this. That's why we use C-beam when we have a tall section. But for horizontal mullion deflection, there's a tab here. And you can enter the values, which are mainly the height. So I'll put in 10 for the height, and the width, the module, the wind load, but we're going to look at dead load, and then the glass type, which the reason why glass type is important is because it gives us the glass weight, and that's what we really care about. Once you hit calculate, it gives you a value for an I value, inertia value required for quarter points, setting blocks at quarter points, and setting blocks at eighth points. And we compare this value with the member that we're using, and it's IXX. So once we analyze that light of glass, we hit print, and it adds it to a queue. And so you'll analyze your next light, you'll hit calculate, and then you'll hit print, and there's another item in the queue. If you make a mistake, well, it's already added to the queue. You can't really look at multiple lights at the same time. You can't really look back until you go to print. If you accidentally hit print, purge print queue, then you start over. So this tool is really great. I believe it's from AWS, but there's some improvements that we could definitely make to it. And then another thing that we have to do when we're looking at these glass lights and the mullion is we've got to go into the parts library or the detail library, find our condition that we're looking at. So maybe I'm analyzing a light of glass, and the member that the light of glass is sitting on is a sill, captured sill. So I've got to take the strongest part of that member, which is the part back here, not out in front. And I'll create a copy. And Zach created a really cool tool that's called section properties. I'm going to select the entire member, not just the outside part. Make sure I select the hollow. And it runs section properties. The orientation matters as well. So this is the orientation that it is on the building. I need IXX, which is 1.294. I'm comparing this number to the value that it gives me in this program. We decided that we can create a better tool if we learn if we derive the equations ourselves. So we went ahead and did that. So we've got this tool in Excel where it does the same exact thing. You type in your part, you type in the I value of the part, let's say 294. You could type the IYY as well if you want to check for wind load. Right now we're checking dead load. I can select a glass type or hit custom and type my own. I'm going to enter the dimensions of the glass, maybe the wind load, and then it tells me the same information that the Simple Beam program tells me. We just derived the equations for deflection. And then we also added fields for setting block length, and if it's more than 6, and the distance from the edge. It should highlight the text in red if it's less than 6 inches from the edge. So now that we've got this tool, we can enter multiple items, infinite items. We can analyze infinite items. And this is where Revit and Dynamo comes in to play. So we created, so I've got this new spreadsheet that's basically the same thing. This is what I'm using to get pretty much every glass light in the Revit sales model. I can pull from the schedule using Dynamo. I can pull the glass height, the glass width, a part alias. It's going to tell me if it's captured in Viso, if it's a sill, a horizontal, or a stack. And then from that, I can determine a part number. Right now, we're using the base catalog parts. I'll talk a little bit more about that in a bit. Using the Dynamo script, it populates all of the glass light data, and then I can look at all of the glass light data on one sheet, maybe use a pivot table to organize that data, and run the deflection calculation on all the glass data on the entire building. Then I can go back and reference the unit ID or location ID, maybe look at where that occurs. So this is the evolution of where we've come with one of our engineering checks, which is horizontal deflection. With that, I'm going to go to another Jamboard I created, talk about future visions and what we could expect in the future. So right now we have a Dynamo routine that collects the glass size and the horizontal and assigns a horizontal part number. And we use that to calculate deflection. Right now we want to use that as a back check in our Jumpstart 2 engineering process to see is there anything that we missed? Are there any unique lights that we need to look at? And are we doing our work right? And maybe lots of different ways we could analyze the data too, to see what we can expect and find patterns, help us do our work better. So could we automate other things using this current routine? I could see that we could automate glass deflection using the current Dynamo routine that we have. We could automate finding the sealant bond width for each glass light. And we can even look at having glass over 50 square foot to see if it has a non-removable captured horizontal. These are all checks that we do in our Jumpstart 2 process that we can possibly automate using the one existing Dynamo routine that I've created. What's in the works? So right now we are giving the part number an alias, because from my understanding, and I had to learn a lot about the sales model in this process, and how the sales model right now, it doesn't correlate to the drafting model. It's different from the drafting model in lots of ways. And the main thing I realized is there's curtain panels and they have different parameters. And that's how, Amy, correct me if I'm wrong, you guys assign data and things to the curtain panel, and that's how things are identified in the curtain panel with parts or glass. And so right now we don't have a way to connect the exact part number used and with the glass that it's sitting underneath, the glass that it's supporting. And with that comes a timeline, right? So we've got 3 teams working at once. Estimating's got to tell us what's the glass size. We've got to determine what's the glass weight, sales model, and then we've also got to determine, do we need a new part? Do we need new part number to support that glass? If we do, well, sales model needs to know that new part number so that they can put it in the model so that we can have that information to connect the part number to the glass. And then eventually estimating needs to know everything that we're working together on so that they can price the building. So it's a lot going on at the same time. And so one of the things that we question, Amy and I, is, well, how can we have Jumpstart determine the part numbers and give it to the model team to model so that we can have that information to do our engineering calculation? But Amy is working to maybe add a parameter in the curtain panel to make that connection. So we're working on that right now. So yeah, we've got Revit that feeds information to Dynamo, to Excel. Excel can go back to Dynamo and back to Revit. Something cool here. So from Jumpstart to model opportunities, earlier Amy showed an example of how you can export something from Revit into Excel, and then you can change the value in Excel and put it back into Revit. I feel that's super revolutionary because that's a lot of manual work that you don't have to do anymore. You're doing it in Excel and you're doing hundreds or thousands of line items and you're just feeding it back to Revit and it's changing that parameter in Revit. That's super revolutionary, and in the future we could use that, for example, with glass weight. If we want to change, we need to change the glass weight, we can do that manually with a click of a couple buttons instead of you have the modeler having to go in and select which lights and where to change it and what to change it to. What else can we obtain from the model for engineering? I see a potential for the model to identify corner zones and highlight corner zones. Corner zones are something that drafting, the PM, engineers, we all use and understand. That would be really cool if we could just scroll through the model and we could see where the corner zones are. And Zach will be working on how to integrate vertical mullion deflection into the model. Jumpstart will assist as needed there. Right now we use C-beam to do that. And I'll just show maybe a quick example of what that looks like. But we've got the code for this, so it's really exciting, and hopefully we can implement that in the future. So I want to add an anchor. I want to add a Hilti anchor. Oops. I want to add a Hilti anchor. And then right above my Hilti anchor is my chicken head. So I'm going to add a hinge for my chicken head. And then we analyze the mullion. So let's say this is a sill. Here's the anchor. Here's where my chicken head is, separating the unit. Got 2 units. Here's the head. And then I'll do the analysis. Here's the analysis. It tells me my maximum deflection. And my favorite thing is to look at the chart showing where the maximum deflection occurs. This is a program that we use right now, and it'll be super exciting to see if we can integrate that into Revit and have Revit do that. So tying the part numbers to the glass and the units is super critical here. So yeah, this is kind of an overview of sort of what we do and what we are hoping to do. And in the future, this current process and how we do it and the order that we do it can definitely change. And if you have any repetitive processes that you do or data that you look at, lists that you have to make and analyze and organize, Dynamo is a really cool tool to be able to process that and look at lots of information in one place. Thank you for listening. I hope you guys learned something, and please contact Amy if you want to learn more about Dynamo.
Awesome. Thank you, Sahar. That's awesome. Cool stuff. Super exciting. Gabe, how are we doing on time?
We're behind.
Yeah, we're behind.
We've been behind
so
for
we
a while.
might have to cut on the questions for this, but we can have maybe discussions during lunch about it.
Okay.
Let's move on to the next presentation, but first let's give a round of applause
Really
to
good job,
Amy
guys.
and Sahar.
Really good stuff.
Nice job.
Really nice.
Good job.
Guys.
That was good.
We'll make up the time for the next one presentation. Good job.
What's the program you use for to analyze the frames, Zahar?
Which one?
The program you use for the analysis?
C-beam.
We can
Dynamo?
talk.
C-beam.
C-beam.
Yeah, C-beam for the vertical
The
mullions.
verticals with C.
Yeah,
Cool.
I used to have like a visual analysis. Is a really great tool.
All right, I'm gonna mute everyone and
So this card, oh, I don't know if we'll have everyone, but doesn't the material have these options? I was wondering what options.
There are some things that we can put in the material, but it is limited. Yeah, which options? Good question. The I values, the
Yeah,
glass weight, because we talked about the glass weights, hard I did.
Yeah. Section properties, we should add section, require section properties as profile parameters.
That is possible. That is from me actually. So what I want to say, if you put all required section properties for our initial structural CALs, then you don't need to like re-enter those, you know, from your CAD. Means right now you are entering manually, correct? Section properties.
Yeah, everything is pretty manual right now.
Yeah, so once we like put once we have those as a parameters in the profile itself, then you can extract that value from the profile.
Right, the only thing you have to be, oh, sorry, go ahead, Sahar.
Oh, go ahead.
Oh, I was just gonna say, pretty much we could load up the Revit model with all kinds of great stuff if we want to. My biggest thing with that, as you probably are getting tired of hearing, is just the change management. If a profile's properties change, we have to remember to go back and update it somehow. Maybe it's automated or maybe it's manual in the model to make sure.
When you create a new profile, you are not running the section properties. I think we should actually, and Jumpstart always do that, isn't it?
We only look at, I mean, the section properties from CAD, Jumpstart pretty much uses that command to get the IXX and IYY that we use, like to analyze the deflection of the mullions.
Yeah, that's
we
what I
do it manually. So we'll look at the worst case on the job.
No, what I'm saying actually, see, when you are entering this property, so when we are, suppose you are, we have new profile request, right? So this section property will remain same for that profile forever. So next time when you are using that profile, you don't need to like go to this page and enter manually into the, but it will take the values from profile itself.
Yeah, that's a good idea.
Yeah,
for
so
it to be
that's what
like
I want to say. Yeah.
a lot of times Jumpstart is also just making profiles on the fly. So they need to be able to just make it on something that they just drew, you know. But yeah, there's no place in the portal where those values are stored anywhere right now. It could definitely be baked into a process somewhere, probably Heather's die process where she gets the final die print, and an actual IXX, IYY published value can be put onto the portal where anyone can look it up under the engineering tab. But yeah, right now they're not stored anywhere, which is going to be one of the problems that I'm going to have when I try and automate the vertical deflection calculations out of Revit. Is I don't have any of those section properties anywhere. So I either have to calculate them on the fly based on the the die picture, or have them stored somewhere in some earlier process.
Yeah, I was thinking, you know, that thing we use for SecProp, unlike everything else I ever did in my life, that thing's a block. And those are the little attributes, right? So it would be fairly easy if we just stored, you know, if we had another library that was just the part with the section property run on it, it'd be pretty easy to pull those attributes out of the files. You know, if we didn't want to put them in a database, if we just wanted to have them, you know, just run SecProp on, because you could really literally have, you know, because I think for Jumpstart, they'll have a bunch of them in one file with a bunch of different section properties run, but each of those blocks tells you the part number and then the IXX and IYY and everything. So we could probably just do it that way, just read it out of the blocks. And that way Jumpstart doesn't have to change the way they do their Jumpstart drawings at all. And then, you know, we could just store the other ones on the server.
Yeah, so my question, yeah, I had the same question. When suppose we have like a new profile, Jumpstart, maybe like analyzing that for particular location, and they may be coming up with some value of IXX, right, from from the parts, right? So
Right.
at this time, if they will like they will, somebody will, Esli will be there actually always when there is a profile is coming in the picture. So they will send those values ultimately, or they will display those values on their Jumpstart document. So when Esli is finalizing the profile and giving to operations, those value may be there. Or
I feel like a big piece of the puzzle is the part number. Like if we just knew the part number and we could connect the part number to the light, to the unit, or whatever it is, like we can have a whole list of part numbers and I values and like a lookup table. Like that's what I'm doing right now. Is it's just it's looking up on this other tab and it's finding the I value. And like we could easily have a whole list of sec props for all our part numbers. And it's like getting that part number to tie back to where it is on the model and what
so that's right.
it's being used for. Like that's a huge key for.
So that's why I gave my question is for that actually, because you know, if you floated the idea to get the data, suppose to get all the million properties from the model, and like take a take like you will select the maximum, like a worst case million, right, out of that to analyze. So that value will be there in the profile itself. So and when we build that profile, we'll decide which part property we have to use, which IXX of the part we have to use for that profile. So once it is entered on into the profile itself, when you extract the data from profile, you can extract the IXX value also that has been used, that we can use for that profile.
Yeah, depending on where we, you know, putting all that, that's part of what I'm working on right now with Dynamo and restructuring at least in the sales model, is getting all that to jive. And Sahar and I have been looking at some stuff and we're working on it, we're getting there. But again, it just comes down to how much do you want to load into the model and the family? We can, or do you want to leave it flexible in case something changes in that die? You know, what if the die has to, I don't know, maybe this never happens. Does the die ever get updated later on and those values change? Or not, you know, and that's my own thing is like,
once you're using that die or that profile into the operations, and suppose for the future project, when you are using that profile, at least it will be available, that value, if you will embed that into the profile. That is my point, you know.
Yeah, that could be one route. That's and that lives with the profile. That could be a route.
Yeah.
Another question was, can we use part numbers from Arcadia system? I'm sure we could. Like, I'm sure when we're able to make that connection with the part number, that like we could load anything and all sorts of information. That's what's really exciting. That's what I think is so cool about parameters and curtain panels.
So right now, let's just speak to that, like the sales model team, we can plug in any system, because when the guys run the, the sales models are pulling aliases, just a placeholder piece of text that describes the shape. And then when they go to run the takeoff, they'll plug in what the actual die numbers are. So if we wanted to analyze an Arcadia system in the sales model, they would do it there at that database. So there are other ways to do it as well.
And right now, do you guys enter the weight too?
The weight is recorded when the final die is processed by Heather. That is in the database.
Right.
Weight per foot.
I think you'll send the database weight per foot and the perimeter for painting.
Yeah, the perimeter and the cross-sectional area.
That's right.
Could Quasar be used to convert a sales model into a shop drawing model with the help of Dynamo? I've been thinking about.
Got my.
I haven't been thinking about Quasar, but I've been thinking a lot about like that connection, and like in the future using the sales model as a drafting model. So I've been trying to like consider that connection for the future as I'm creating these tools.
That's the big question. I think that one's a ways out. Right now we know we can translate it with Quasar, so we have that option. But there are other things we're looking at, a lot of stuff. I've been looking at stuff with Gabe, and I think there are other ideas out there, and we're just kind of looking at a lot of big picture stuff right now to step back and see what we could do and where these things could plug in. So there's a lot brewing out there, even though we can do this right now for sure.
Definitely. There's with Quasar can read the sales models, the sales unit, and convert them, so you don't have to make a wireframe if you're dealing with sales, a sales model. And that's something I've been working on recently. But ultimately, the ideal situation is we wouldn't have a translation process. We're just not sure what that looks like yet, so we have a translation process for now.
Should we be running these Dynamo scripts on the final Revit model? Sometimes there can be big design changes. So yeah, that's kind of like the goal, and for it to sort of be a back check, and even right now for it to be a back check. And there's that timing constraint, is we're all working at the same time. So trying to envision all of this, and maybe the steps change in Jumpstart. Maybe everything is working together. Maybe Jumpstart is modeling and using the model as engineer, like who knows what the future holds. But the model is definitely coming to be a super useful tool. Is this you, Amy? This can be a future state for sure. It depends on whether the sales model can be used eventually throughout the process, or we may need to make a different Dynamo to read the current drafting model format. Another question.
Because I guess there's a lot of stuff, a lot of information on your model already. So they potentially could use that for shop drawings use. Because with the amount of information goes into those drawings, that's a lot. All in, horizontals, glass, gaskets, you name it. It's all in that modeling, the model drawings. So
Even details, yeah. It could be revolutionary.
Correct.
Another question, are these calculations shared with the outside engineer? So the calculations that Jumpstart does is pretty internal. And I think the reason we do them is so that we can anticipate any issues, and so that we can design the building. So by the time shop drawings are done and the engineer goes through all the shop drawings and does all their calculations, we already know what works, what doesn't work, and we've already designed, we've already made sure that the mullions can withstand all the loads that they're experiencing. So there's few changes when we get the calc package. So that's why we do our engineering. I think they do more extensive engineering, and we look at the worst cases. And so we're kind of trained to look at the building, look at the worst cases, make sure those work. And then if we see smaller lights, smaller units, we know that because we looked at this bigger one, that this one's going to be fine. Mm-hmm. We make sure to look at all the unique cases, super wide modules, anything over a 5-foot module, certain glass heights, glass widths, any unique things. But a lot of things are repetitive. So you look at an elevation, and it can be super repetitive. So that's why Jumpstart 2 can take a day or 2 days. Sometimes it can take a week.
Yeah, again, Jumpstart 2 is the most tedious work for Jumpstart team. Package 1 is not so bad, but package 2 is it takes a lot of time to do all this stuff. Because we do glass, we do emulsion, like Sahar says, we take all the building conditions to make sure the emulsion works, horizontal works, and so on. Makes the glass deflection works, and make sure that what happens on Jumpstart 2 needs to be informed to the sales, because that's when you need to let the sales know if the emulsion needs a stiffener or horizontal needs stiffener, or you need kickers and so on. So
yeah, I would say JS3 is more tedious.
Well, JS3, yeah, but I guess it's sort of backwards, right? JS3, you need to do your detail to do your Jumpstart package too, correct?
Yeah, you need to know what the detail looks like.
Yes, yes.
For sure. It's kind of working at the same time. Yeah, pulling in details, checking stuff, measuring stuff, putting it into the engineering.
Mm-hmm.
We have another question. Have you approached AWS or Larson Engineering for corner zone identification and Revit model? I think if we were to identify corner zones in Revit model, it would be, we know how to identify the corner zones. So it would just kind of maybe be in the Dynamo schedule or in the Revit schedule or in Dynamo, just telling it to measure each corner. And then based on that measurement, tell us, like, highlight the corner zone distance. I could maybe show you guys an example of.
That's my question, Zahar, because I know that, yeah, it's always like the 10%, but sometimes there's like some vortex that are built or inside conditions where we had it where, well, nowadays we have the preliminary corner review, and sometimes I'm very surprised that you would think that it will be this surface or this side of the wall compared to the adjacent one or the return wall. So that's why I like, rather than us just thinking that we got it, it will be good to kind of run it by them and make sure that we're using the correct criteria.
Yeah, we actually have something on the wiki that I can put in the chat or I can post here, that shows you how to do that calculation for each corner and identify if that corner is a win.
Corner zone.
Corner zone, yeah.
Okay, nice.
Yeah.
But Sahar, you think that we could write some code to do it automatically, so nobody ever has to remember that stuff at all?
Why not? I think it's pretty simple.
It would be really interesting to do, because like that's always the first thing, right? Is knowing where your corner zones are. And it is, I mean, there's a geometric piece, but it's almost like if we can analyze the shape of the footprint, like, I mean, we know the sizes, it feels like we could do it. I mean, it would be complicated, I think, but not more than some of the other things we've done.
Yep.
For sure. I was thinking about, sorry, go ahead.
You guys are putting on the JS1 or 2 package somewhere. I saw that actually. You are mentioning what is the corner zone.
Yeah, we put it on the elevations, but it's
not elevation. I saw on the document because this much dimension from this for this building, there's a corner zone. I saw that actually. I'm always using that value for my corner zone.
Yeah, that's great. We do have it in the JS1 and JS2, and we do highlight it on the elevations, but it would be super cool to also see it 3D too, because the elevations, there's lots of returns that you can't see on the elevations. But it's not, I remember when I first started, it was a little confusing to determine there are some unique conditions that I couldn't figure out, but now that I have a grasp on it, it's kind of more easy for me to understand it. I was thinking about the model one day and kind of realizing, okay, we have floor plans and this all turns into 3D, and pretty much it's kind of like coordinate points. Like each corner is a coordinate point 3-dimensionally.
Yeah.
So thinking about it that way, I feel like we can definitely have Revit just do it for us, or Dynamo do it for us. So that's one of the things that I had on the Jamboard that I wanted to look into next.
Can I join the Jumpstart team?
I think the only place where it might get a little bit not confusing, but throw a wrench into all that is when we have a wind tunnel study, and they identify high wind load areas, and it could be at a balcony,
Yeah, that will be different.
on a flat wall, and sometimes it's at a lower level or the higher level, upper levels of a corner zone, and they may expand that corner zone where it's a higher wind load. So for us, typically we just identify the 10% of the corner zones, and then if they do need, steel reinforcing, just to get that information to the estimator so they could, add that cost. And, we just over exaggerate that. I mean, we just take every corner zone, and I think they even interpret that themselves as far as the estimators just saying, okay, they go around the building. If they have 4 corners, they just estimate that each of those corners and the first 2 mullions, or those corner mullions, the first 2 bays at the corners need steel reinforcing, and just estimate in that fashion.
Yeah, those wind tunnel studies can be super
different,
expensive and precise, and completely different from the standard way to look at a building for corner zones.
Yeah, and I don't know if
how our engineers, like our engineer Larson and AWS, are communicating the corner zone to us, because it is ultimately their responsibility.
Yeah, so that'll be in the shop drawing process once they analyze the full building.
Yeah, they have to give us back.
They do that when we send it out for the preliminary review. That is one of the requests, if they can identify corner zones early, so that way we know when we build the units, 2 factors, reinforcing if there's any, and sidelines. If sidelines it plays a factor in a project. So
they should, according to me, they should like a markup on. We used to do that actually. Markup
no, they do. Yeah, they do. They mark it up for you. That's why that's what I was sharing with Zahar, that sometimes I'm surprised to see that certain sites of the building are either highlighted or not highlighted, to my surprise. So
wouldn't that be too late though? I mean, if we're saying that when tunnel studies could affect, the whole design of the building. I mean, at the time we have shop drawings.
No. This is, so Jumpstart already identified, we have corner zone. Well, of course, there's corner zones and loads associated with it. So by now, if there's any reinforcing, they already know. For us, it's just a back check to make sure that we do allocate the correct corner zones in our unit. So when first time we draw it, it's correct. We don't have to go back and now change units.
Yeah, there's other factors, the width of the units at the corners. Sometimes we may estimate it or see that it's just typical, widths at going to the corner, and then they, want to merge those two, that smaller light at the corner. So now that changes that width of that mullion, and how that, how the wind loads affect that unit and that intermediate mullion. So those do change, reinforcement requirements sometimes. We may look at it, and at a typical module, 5-foot module, we're okay, even at the corner zone loads. And then you know, they take that 5-foot module and they make it a 7-foot module, you know, at the corner just to make that unit simpler, or just to make it a single unit. Now you got a 7-foot unit, and now that changes some of that criteria.
But just so we're all on the same page, right? So Jumpstart package number 2 should have a little footprint of the building that shows where the corner zones are. And then when we first get the job, we should be doing a preliminary review with our structural engineer, AWS or Larson, and they should be confirming our assumptions in Jumpstart 2. So shop drawing should be maybe not even started at that point. You know, we're trying to, it should be during that period when Jumpstart's reevaluating the package, making sure everything's good. Like that should be the way things go out. I mean, if they're not, we can work on it, but it should be like that. It should be part of Jumpstart 2 when we first bid, and then it should be part of the review that AWS or Larson does for us right when we get the job, you know?
Yeah, on Jumpstart 2, we have those deflection elevation that shows you where the corner zones are.
Yeah, exactly. Yeah.
That's why I think we encourage the when we awarded the project, we encourage the drafting team or the PM should look at our packages.
Yeah, of course.
To
do that actually.
Yeah, that's, I think in the past, I know I go to a kickoff meeting with when the job is sold, and we don't look at the package at all. You spend a lot of time. We spend a lot of time doing all the pre-calculations, and they don't look at it. So.
Yeah, we're going through those, you know, in that pre-drafting checklist. We walk through all those packages, make sure we have everything we need. And then we should be, like I said, the PM should be getting the engineer on board pretty quickly, and they should be doing a quick review, you know, because there always could be something, you know, that you missed or something, right? So,
right.
Because again, you don't want to draw it all twice, right? So.
Mm-hmm.
But I think that's a good point, is even adding, you know, footprint or just a, you know, a snippet of that floor plan. So you can see the geometry of the building. I mean, you know, just seeing the elevations don't tell the whole story, right?
Right.
We show a corner zone, you know, highlighted on that elevation, those deflection elevations. But, you know, when you see that snippet of that floor plan, then you get a better picture of, you know, what that corner zone is actually, you know, highlighted.
Here's the handbook. I put a link of the handbook on the Jamboard.
Yeah.
Shows different conditions, some questions and answers, and how to calculate that. This is why I feel like it would be pretty simple to automate that calculation, have it for each floor plan, and maybe even highlight it on the 3D elevation.
What does the green color mean?
The green means it's good. The red means it's corner zone.
No, so that's the thing. It's like, those are the things that, like, for me, you look at it and you think, oh, both of those should be red, meaning corner zone load, but they're not.
No.
Well, the green ones, that was more markup. When I received, I got those from AWS.
It is
the
correct.
engineering, what do you call it? Interpretation, if they want to consider a corner zone. That's if you scroll up, Zahar, can you go up? Up more. Here. Stop. See the green? That was the question, and the answer was on this side here.
So, Sahar, have you guys looked at ASC 716 yet?
Yes.
We're using that now.
Okay, because they have, in the commentary, they clearly give real good definition to the non-rectangular building corner zones now.
Okay,
It's
cool.
new. It's new. They didn't have it in earlier versions, but a lot of these conditions that are, you know, noted as conservative, they've got those defined now pretty clearly. They tell you, like, if it's an angle, what angle, if it's a corner zone over this angle or under this angle, that kind of thing.
Projection. So here, this green number is under question.
We should look at that. Thank you, John.
Yeah, it's in the commentary it's this C30.6. Well, it's figure C30.3-2.
Can you say that again?
Figure C30 dash or 0.3-2.
The general rule I kind of like to think about is we have a corner zone distance that's determined, and if the return
is less.
Yeah, if the
less
return
than the
is,
corner zone, then it's not a corner zone.
so if your corner zone distance is 20 feet and your return is less than 20 feet, then that return is going to be a corner zone.
Correct.
But it's just,
Yeah, they have that actually defined in that diagram now.
Great, thank you, John.
Yeah, that was always kind of a rule of thumb before that everybody used, but they never specifically defined it, and now they have it defined, so which is nice.
Well, that thing got changed when we did 710, John, from 705 to 710. Now changing back again to on the 716. I think they're going back to the 705. I think.
Yeah.
Yeah. Even the lows now are back to the similar to the 705.
Thanks, guys.